Good day, everyone. Today we will be discussing about the images formed in lenses. So maybe you're wondering why you are looking at this particular example. Well, you are right. This is a mirror. Okay. So this is just some sort of review from the previous discussion. Okay. So my point is in showing you this um, particular illustration is that I just would like to point out that mirrors reflect light in order to form an image. So, for example, here we have this object. Okay, so we have say object one. So, if there's light, light would go through these lines. Okay, so we have the light rays here are represented by the principal rays. So these are the principal rays. As you can see, in mirrors, light needs to be reflected in order to form an image. Okay, so mirrors form these images by reflecting light, and the point at which these light rays converge or intersect, then that is the point at which the image is formed. Okay? So again, lenses form images by refraction. Okay, so refraction is the process by which light bends. Okay, so when you say refraction, refraction is the bending of light rays. Okay, so lenses form images through refraction. Okay, so light bends, and then those lights that are bended, they intersect at a certain point. Okay, like for example, in this illustration here, they bend and they intersect at a point. Okay, so where the intersection happens, okay, or where the light rays intersect, that is the point where the image is formed. Okay, like for this example, okay, so we have the object located here. So these are the principal light rays. They go through, they pass through the lens, and as they pass through the lens, they bend. Okay, and then the principal rays intersect at a point, and then the image is formed right here on the other side of the lens. So let's discuss this one, this particular example. Okay, so let us talk about the location of the object. So this is object one. Okay, so this is object one. This is the center of curvature. Okay, this point here is the center of curvature. This is the focal point. So like mirrors, lenses also have focal points and center of curvature. Okay, so same uh, on the other side of the lens, we have focal point, and we also have center of curvature somewhere here. Okay, so say let's put the object here. So I have identified this point here as the center of curvature. No? So this is twice the distance from the lens. Okay, twice the length of the focal length. Okay, so times 2 times f, then that's your center of curvature. So this is actually the radius of the circle. Okay, so this is the center of curvature here. This here must also be another point or another center of curvature. Okay, so let's talk about the first case. Okay, what is the image formed if the object is beyond the center of curvature? Okay, so again, we are talking here about lenses. Okay, so it's beyond the center of curvature. So in this case, the image is formed on the other side of the lens. Now, in the case of lenses, if the image is formed on the other side, we call this image as real image. Okay, so again, if the image is formed on the other side of the lens, of course, if the object is here and then the image is formed here, we call this image as the real image. Okay, so this is the object, this is the real image. Okay, so what are the characteristics of the image formed when the object is beyond the center of curvature? Okay, so under lenses. So the object is right here. So the image formed by this lens is inverted. Okay, again, that's inverted, real, and as you can see, it is smaller than the object. Okay, so if you study the principal rays, this first ray here is parallel with the optical axis or the principal axis. The broken lines here is the principal axis or the optical axis. Okay, so a straight line is drawn to represent the first ray that is parallel to the optical axis. And then it passes through the lens and then towards the focal point. So that's your first ray. Okay, so you have here a line parallel to the optical axis, and then from this point, going through or passing through the focal point. So that's the first ray. The second ray is just a straight line from the head of the object, okay, drawn towards the vertex, passing through the other side of the lens. Okay, so it's just a straight line. And then as you can see, this line here, okay, converge or intersects with this uh, line from the first ray. Okay, so we call this rays as refracted rays since we are talking about lenses. Okay, so the first two refracted rays intersect at this point. And then the third ray is drawn from the head of the arrow through the focal point here, okay, on this side of the lens, and then passing through the other side. Okay, so this refracted ray is parallel to the optical axis. Okay, so again, the third ray passes through this focal point here, and then it bends or it refracts towards the other side of the lens, parallel to the optical axis. Again, it intersects with the first two rays. Okay, so forming the real image at this point. Okay, so specifically that is between the focal point and the center of curvature on the other side of the lens. Okay, so that is the first case for our convex lens. Okay, so if the object is beyond the center of curvature. Okay, second case or second possible scenario. If the object is located exactly at the center of curvature, okay, so you have noticed that as I move the object towards the center of curvature, the image also is moving towards the center of curvature. Okay, so that's the second case. If the object is at the center of curvature, the image on the other side of the lens will also be formed at the center of curvature. Okay, and then here the image is real, Okay, since it is formed on the other side of the lens, it's real, it's inverted, and has the same size of the object. Okay, again, the image is inverted, real, and same size as the object. And also, the image is formed at the center of curvature. Okay, so same procedure. The first ray is drawn from the head of the object or from the head of this arrow parallel to the optical axis, and then it bends, passes through the lens towards the focal point. Okay, that's the first ray. The second ray, still the same. So just draw a straight line from the head of the arrow passing through the vertex here, and then it should converge at this point with the first ray. And then the third ray is drawn from the head of the arrow towards the focal point. Then it refracts, and the refracted ray is again parallel to the optical axis, and they should meet at this point, okay, where the real image is formed. Okay, I hope that is clear for the second case. Okay, that is if the object is located at the center of curvature. Now, if the object is located between the center of curvature and the focal point, so the image is most likely be formed beyond the center of curvature on the other side of the lens. So just like this. Okay. Okay. Again, if the object is between the center of curvature and the focal point, the image will be formed beyond the center of curvature on the other side of the lens. Okay. So here the image is still real. It is a real image. It is inverted and is enlarged, meaning the image here is bigger than the object. Okay, so that is the third case. Again, the principal rays are drawn similar to the first two cases. Okay, so the first ray is parallel to the optical axis, refracting through the focal point here on the other side of the lens. Second ray would be passing through the vertex, and then it should meet up with the first ray at this point, and then this is the third ray drawn from the head of the arrow towards the focal point, and then refracting parallel towards the other end of, I mean, parallel to the optical axis towards the other side of the lens, and they meet up here. All the three refracted rays intersect at this point where the head of the image is formed. Okay, so the image is enlarged or bigger than the object, inverted, and real. Okay, next case. If the object is located exactly at the focal point, so the refracted rays will be parallel to each other. And so there is no image formed by the convex lens if the object is located at the focal point. Okay, that's the fourth possible scenario. Now, the fifth scenario would be if the object is between the focal point and the vertex. Okay, so as you can see, it is quite interesting because most of the cases they have the images formed on this side of the lens, but in this case, if the object is between the focal point and the vertex, the image will be formed on the same side of the lens. Okay, so again, the image is formed at the side where the object is located. So, so that the object and the image is on the same side of the lens. So, this is the object, this is the image of the object created through this lens. Okay? So since the image is on the same side of the object, this image is a virtual image. Okay? So This is the object. The first ray is this. Okay, so it refracts through the focal point. Okay, refracts on the other side of the lens, passing through the focal point. And then the second ray is just simply being drawn straight no, from the head of the mirror. From the head of the object or of this arrow towards the vertex. Okay, and so you just extend this part of the refracted ray, and then the two rays should meet at this point. Okay, so that is where the image is formed if the object is between the focal point and the vertex. The third ray is drawn here, okay, at the height of the image, and then passes through the other side of the lens. And then you just extend this, and this should intersect at this particular point where the virtual image of the object is formed. Again, at the same side of the lens. Okay, so again, here the image is enlarged, or that is bigger than the object. The image is virtual, and it is upright. Okay, so that is all about the convex lens. How about the image, or the images formed in concave lenses? Okay, so we have here a concave lens. We have here the object as represented by the arrow. Okay, so let's put some light. Okay, so in concave lenses, in point at all points, there is always a virtual image. Okay, so in concave lenses, the image is always located at the same side where the object is located. Okay, so again, where the object is located, that is where the image will be if you are dealing with concave lenses. Okay, so if I put the object here, you can see the image located at the same side of the lens. If I bring the image near to the lens, the image tends to be bigger but is still smaller than the object. Okay, so we only have one scenario or case for concave lenses. Okay, so as I bring the object farther away from the lens, the virtual image is also is decreasing in size. Okay, so it's getting smaller and smaller. If I bring the object towards the lens, the virtual image is getting larger than before. Okay, but is still smaller than the object. So, uh, if we are talking about concave lens, the image produced is always virtual, always smaller than the object, and is always upright. The principal rays are drawn from the head of the arrow. Okay, so this is the first ray from the head of the arrow towards the vertex. Okay, so towards the vertex. And then the second ray would be from the head of the arrow towards the lens, parallel to the optical axis. And it refracts like this, so that if we extend this line, it will pass through the focal point. So you should form an X with the first ray. Okay, so this is the first ray, and then this is the second ray, refracted light from the second ray, and you should form an X. So the point at which they meet is also the point where the virtual image is formed. Okay, so this is the third ray from the head of the arrow towards the lens, and then it passes through the opposite side, and this must be also be parallel to the optical axis, and then you just extend this line towards the height, or towards the height of the virtual image. Okay, so that you have three principal rays. And it is always like that. The principal rays are always drawn like that, the way that I have described it. Okay, so dealing with concave lenses and the images that it and the image that it forms is quite simple. Okay, so that's it about concave lens.